Alright, so today, basically doing the opposite of what we did yesterday. Today we're going to solve a right triangle, or determine the measures of all 6 parts of a triangle. And you can solve a right triangle if you know either 2 side lengths or 1 side and 1 acute angle measure. So as long as you've got those 2 pieces of information, you got 2 of the sides or 1 side and 1 of the angles, it's not the right angle, then you can solve for everything else in the triangle. Now, for an acute angle A, it says that the sine of A equals x, then the inverse sine, or sine to the -1 of x, is equal to the measure of angle A. If the cosine of A equals x, then the inverse cosine of x equals the measure of angle A, and the tangent of A equals x, then the inverse tangent of x equals the measure of angle A. So, what we're looking at today, if you're on a calculator, the sine, cosine, and tangent buttons that we used yesterday, if you look just above those, there's a sine to the -1, cosine -1, tangent -1 for the second function of those. So basically what this part right here is telling us is that if we know what the sine, cosine, or tangent of an angle is, then we can use that button, the inverse sine, cosine, or tangent button, and basically go in reverse and use the sine to find, or cosine or tangent to find the measure of the angle. Right, where yesterday we were using the angle to find the sine or cosine. Now we can use the sine or cosine to find what the actual angle is. So here we want to use a calculator to approximate the measure of acute angle A, rounding it to 1 decimal. So it says the sine of A equals 0.36. So just like this first line here says, if the sine of A equals 0.36, then the inverse sine of 0.36 so if I take the inverse sine of 0.36, then that'll equal the measure of angle A. And just like yesterday, you would want to make sure that your calculator is running on degrees, not radians. So inverse sine of 0.36. So second function, sine button, 0.36. Enter. So that tells me that's basically a 21.1 degree angle, rounding it to 1 decimal place. 21.1 degrees. Alright, so the next one tells us that the cosine of A equals 0.67. So to find the measure of angle A, it's the inverse cosine of 0.67 equals the measure of angle A. So second function cosine, 0.67. And that'll be 47.9 rounded to 1 decimal place. then lastly a tangent of 1.24. So the inverse tangent of 1.24 is going to equal the measure of angle A. Tangent 1.24. So 51.1 degree angle. All right, so 51.1 degrees is the measure of angle A for that one. All right, so now we're looking at solving for a missing side. And so this is where we really apply what we did yesterday. Okay, so we're given one side length, and we've got one acute angle here. And we want to use those two pieces of information to figure out what the length of this one side AC over here is. So if I'm focusing on angle B, then side AB is what side of that triangle in relation to angle B? And that's our hypotenuse. And then AC would be what in relation to angle B? Right, so we're given the hypotenuse, and we're trying to find the opposite side, right? So which trig ratio dealt with the opposite side and the hypotenuse? The sine, right? Some old hippie, OH. So sine equals opposite over the hypotenuse, right? So we know that the sine of 25 is going to equal the opposite side, which in this case is our x, over the hypotenuse, which is 13. And then if we wanted to solve for x in this case, what would we need to do? Get x by itself. All right, we got 13 in the denominator here, so we need to get that 13 to the other side. So technically it's x divided by 13, so to move it we got to do the opposite math. So we'll multiply both sides by the 13. Cancel that out. And so now I know that 13 times the sine of 25 is going to equal x, right? And so now I can go to my calculator. It decides to load here. So 13 times the sine of 25. That's going to give me 5.494, or just round that to two decimal places and call that 5.49 equals x. All right, so then for B, we're given a 51 degree angle here. And we're given side FD and trying to find side ED. So side FD is what side in relation to the angle? FD. That's the adjacent side. And X would be the hypotenuse. So we're given the adjacent side, trying to find the hypotenuse. So then we have to think which trig function deals with the adjacent side and the hypotenuse. Cosine, right? Because cosine is equal to the adjacent side over the hypotenuse. So we know the cosine of 51 degrees is going to equal the adjacent side 3 over the hypotenuse, which is our x. So now in this case, to get x by itself, x is in the denominator. So we're going to multiply both sides by the x to get the x out of the denominator. So now we have x times the cosine of 51 degrees equals 3. And then to get x by itself, we need to move the cosine of 51 degrees over to the other side. So they're multiplying there, so we're going to divide by the cosine of 51 degrees. So my x value is going to be equal to whatever 3 divided by the cosine of 51 is. So that's when we go to the calculator. And say 3 divided by the cosine of 51. It's going to give me 4.76. Looks to the right, it's 7, so 4.77. Alright, so then C, we got a 34-degree angle. We got side GI, which would be what in relation to the 34-degree angle? It's straight across from it, so it's the opposite side. Trying to find X, which is on HI, and HI is what side? It's adjacent. And so now we have to look, we've got an opposite side trying to find adjacent, so which trig function goes with opposite and adjacent? Right, tangent. This tangent is going to be equal to the opposite side over the adjacent side. So the trick on these is you've got to recognize, based on the piece you're given and the piece you're trying to find, what trig function fits into those two pieces of information. So we're going to do the tangent of 34 degrees is going to equal the opposite side, which is 4, over the adjacent side, which is the x. And go to the process to solve for x. So x is in the denominator. Multiply both sides by the x. So x times the tangent of 34 degrees equals 4. And then to solve for the x, we divide by the tangent of 34 degrees. And so 4 divided by the tangent of 34 be 5.93. Questions on those before we move on? Anybody? All right. So then, on to these last three. All right, so these three we are solving the triangle. Which when we say we're solving the triangle, we're finding measure of everything that we don't have a measure for. Okay. So this one's missing a little box there. So right now we have one side, ST. We got one angle measure, angle S. So we got to figure out the measure of angle T. We got to figure out the length of US and the length of UT. So we got three pieces of information we've got to solve for here to solve the whole triangle. So first off, we know that since it's a right triangle, the other two acute angles have to add up to equal 90 degrees, right? So we know that 20 degrees plus the measure of angle T has to equal 90. Or subtract 20 degrees from that, both sides. So measure of angle T, 70 degrees. So then now we need to solve for the other two sides. So we've got one side, we've got an acute angle. And if I try to find US here, I've got ST, which would be the hypotenuse, right? And side SU is the adjacent side. So I'm looking at trying to solve for US here. It's the adjacent. We know I have the hypotenuse. So we're going to use the trig function that deals with the adjacent and the hypotenuse, which would be cosine. So the cosine of 20 degrees is going to equal the adjacent side, side SU, over 12. And so then we would multiply by 12 on both sides. Both times the cosine of 20. So go to our calculator. 12 times cosine of 20. That's 11.28. And then we can also find the length of UT by doing the same process. Well, not exactly the same, because from the angle, the 20-degree angle, it's the opposite side. So opposite and hypotenuse. We're going to use the sine function. So we're going to say that the sine of 20 degrees is equal to the opposite side, which is UT, over the hypotenuse 12. Multiply by 12 on both sides. 12 times the sine of 20. Give us our answer there. So 4.10. All right, so now we've solved the triangle. We've got all three parts that we're missing figured out. So all six sides are accounted for, or all six parts, I should say. All right, so another triangle to solve. This time, they're giving us two sides. So we've got to find both of the acute angles and the hypotenuse. So since we have two sides of a right triangle given to us, finding the third side, we're going to use the Pythagorean theorem. So get an a squared plus b squared equals c squared. So 8 squared plus 10 squared equals c squared. 64 plus 100 equals c squared. 164 equals c squared. Square both sides. And we can break down that square root to the simplest form. So 2 and 82, 2 and 41. 41. We can pull out a pair of 2's. So 2 square roots of 41 equals c, which is technically b here. Right? All right, so we got that side figured out. And now we can look to solve for the two angles. So start with angle A, and to make it easy, I'm going to try to avoid using the 2 square roots of 41. So from angle A, we got two sides. We got 10, which is on the opposite side, and 8, which is the adjacent side. So opposite and adjacent would be tangent. So I know the tangent of A is going to equal 10 over 8. And since I know what the tangent is, then to solve for the angle, I'm going to use what we started off with. The inverse tangent of 10 over 8 is going to equal the measure of angle A. So, my calculator. It's a second function tangent. That's 10 divided by 8. It'll be 51.34. And then to find the measure of angle C, I'm going to go through the same process. I'm going to use the 8 and 10, but now from angle C, 8 is going to be the opposite, 10 is the adjacent. So the tangent of C is going to equal the opposite, which is 8 over the adjacent, which is 10. So the inverse tangent of 8/10 should equal the measure of angle C. So second function tangent divided by 10 give me 38.66. Really and truly, I kind of overdid it because we could have just subtracted 51.34 from 90 degrees and also gotten 38.66. But either way. Alright, so then the last one here, we're given a 20-degree angle, trying to find the other three parts. So we know the measure of angle S plus 20 degrees has to equal 90. So the measure of angle S equals 70. And so from the 20-degree angle, 15 is the hypotenuse, R is the opposite, and S is the adjacent. So to find R, the opposite side, we're going to use the sine of 20. It's going to equal the opposite side, which is R, over the hypotenuse, which is 15. Multiply by 15 on both sides. So 15 times the sine of 20 degrees is going to equal R. And 15 times the sine of 20 should give us 5.13. And then for S, it's the adjacent side. So we're going to use the adjacent and the hypotenuse, which is going to be cosine. So cosine of 20 degrees is going to equal the adjacent side S over the hypotenuse, which is 15. Multiply by the 15, get the S by itself. So 15 times the cosine of 20. The 14.095, so 14.10. That side length. Questions?